So in chapter 4, we did discussion about flange basics. So let me tell you what flange is. Is um, flange is the mantle that's used to connect an equipment to pipe, or is it's a flange is a ring-shaped device designed to be used as alternative to welding or threaded various pipe system components used throughout the piping system. So it can be used as a connection within pipe to pipe, pipe to equipment, because the equipment has what we called a nozzle, and a nozzle is either for fluid inlet or for fluid outlet. And that nozzle has what we have what a flange, which gives a connection in between and that equipment and the piping system. So pipe now is being rated in pounds. That is rating of flange now is being rated in pounds now. What is pound rating? What is rating of flange? Rating applies to flange may be best as defined as the maximum pressure allowed by process piping code for a specific temperature at which the flange will be operating. So that is just it. So that specific temperature at which that flange should be operating is what we call pound rating. And that pound rating is categorized into several categories for forged steel and several categories too for cast iron, which are the for a forged steel, which is class 150, 300, 400, 600, 900, 1005, 2005. Why for cast iron, they have their own also. So if a line is operating at a certain temperature and pressure, they have a particular pound rating of that flange that can serve for that purpose. And note, the process engineer is the one that is responsible to tell you what pound rating a line is running, if a line should run under. If the process tell you guys, if the process guys say 900 or 600 or 150 or 1005, that's what you should follow when designing your process, your process plant. So that is just it. It's typically as pound rating increases, so will the flange diameter and thickness also increase. Yeah. So that's why you may come across this flange is bigger in thickness than this flange, is because they are not of the same pound rating. They are of different pound rating. So for flanges are categorized into two two forms: facing and the neck. Facing and what? The neck. So now for facing, flanges have three type of faces, which is the flat face, the raised face, or the ring type joint. So for the flat face now, the flat face, as the name implies, flanges with flat face are those that have a flat face, level connections surface. Forged steel flanges with flat face are commonly found in pound rating 15 and 300. You know, pound rating 150 and 300. So these are the rating in which this flat face is mainly found. This kind of flange it does not give you a really strong connection. It leaks a lot. So that is why most of the time flat face are not being used. But the wet neck, no, but the raised face, this is a type of flange that has a raise that is available to a raise from an extruded surface, from each surface, that gives a proper flange to flange connection. Yeah, this one gives a better flange bond and seal than that other one, and is readily available, and it is affordable also compared to the ring type joint connection. that which this same type joint connection, as the name implied, it has a ring that is engraving on both of the flange. This connection is actually very strong. It's very, very strong. But the problem is that the metallic ring that is being used to create a tight seal between the two flanges after being subject to much compressive force in order to seal that flange to flange connection. Once you want to maintain such a line and you tends to it is very hard to disassemble such connection, and even if you disassemble such a connection, you can't actually reuse it again. You have to put a new flange, and this ring type connection is actually very, very expensive. They use it on lines that will never be due for maintenance, and even if it has stayed for so many years, if they want to maintain it, they change the entire flange and the entire piping system. These are for that is the time that I think they are going to use such a such a pipe system, such a flange. So that's just now the main type of flange. Now we have different type of flange, which are the wet neck, the threaded connection, the socket thread, the slip-on flange, the lap joint, the reducing flange, and also the blind and orifice. So let us start with the wet neck flange. This wet neck flange has has an extruded back in form of a neck and a groove that you can actually weld directly to a pipe. That you can actually weld directly to a pipe. That is just it. It has that groove, so you don't need to bevel the edge again. You just need to bring the pipe if already beveled and then just weld. That is the frequent kind of flange that is being used in the process industry. And the slip-on flange is a kind of flange compared to the wet neck. You only need to let me show you a picture online. Slip-on flange. Oh, no connection. Okay. No, the slip-on flange is like um a flange that has a hole that is of the same diameter of as the outer diameter of that pipe. Then the pipe goes into the flange, and once the pipe goes into the flange and the pipe are being welded together on on the two ends of the flange, which is at the surface of the flange to be connected, you weld the pipe to the flange, and at the back you still weld the pipe to the flange. Mostly such flange is being used for 2 inches, 3 inches, and half inches, or 1 inches most of the time, but not on 4 inch, 3 inch, not on 4 inch, 6 inch, 5 inch, or whatever. You don't use a slip-on flange. So let us talk about the threaded flange. The threaded flange, just as the name implies, has a threaded connection, and also the pipe that you will use has to be threaded in order to fit in the threaded flange into the pipe. Now, the next one, we have a lap joint flange. Now, this lap joint flange now has a lap that is connected here and to the pipe to create a tight seal between the pipe and the flange. So that is just it. Now, a reduced flange. Let us talk about reduced flange. What does, as the name implies, reduced flange? It is a reduced and mix with a flange, but most of the time it's not advisable to use this reduced flange because of the pressure impact it might have on the flange to flange connection. So the reduced flange, most of the time you don't really use it. Mostly where there it is only when there is limited space, that's when you use this reduced flange, but you don't use it on much distinct cases like that. So Um, so this reduced flange works as the same as that of the reducer. It tends to reduce the diameter of the pipe. Like now, you have a 6 inch line, then you want to reduce it to a 4 inch line, and you don't actually have space to use the reducer. All you just need to do is to use a reduce flange to reduce. Once you put flange on the 6 inch, you put another flange to just just couple with it, and then that flange will reduce it to 4 inch line. So that is just it. So why the blind flange? Like I said the other time, I discussed about cap, how cap is being used to end a line. Now, blind flange is used in a similar way to end the line or to terminate a piping system, but it is basically used to terminate a piping system temporarily. But that line that they use blind flange to end, there is an alternative that line may continue in the future, or have there is a plan for an extension that they have to connect that line to within the nearest future. So that's why they use blind flange to just make make such. Then we have your orifice. On this flange, like I told you, orifice is like a flange to flange connection that has a plate that is inside called the orifice plate, and that flange has a hole in between it that is connected to a differential manometer to actually measure pressure or differential pressure between the lines. So that's just it. Or flow rate. Then we have your bolt and your gasket. What is gasket? Gasket is a fittings that is used in between flanges in order to create a tight seal in between the flanges. So that is for gasket. We have different type of gasket. We have the flexible gasket, the metallic gasket, and the ring joint gasket that is used for the ring joint flange. And we have other metallic gasket also that is used for other these flanges also. So that is just for flange. But the software has been incorporated in a way that once you input your flange connection, it gives you the gasket and the bolt that you are supposed to use, that is supposed to be used for that particular connection. So you don't have to bother yourself about the kind of bolt and the kind of gaskets that you use. So that's just it for this. So this is the end of uh, of gas of flanges. And on the next one, we are talking about valves. So let's talk about valves on this one. Let's talk about valves. Let me move to valves. So let's talk about valves. What are valves used for? What are valves used for? Let me see. What is a valve? A valve is a product rarely noticed by the average person, yet it plays an important role in the quality of our life. Every time you turn on the water, use a dishwasher, turn on the gas range, or step on an accelerator in your car or operate a valve, without model valve system, there would be there would be no flesh, pure water in your home or modern appliance, and no gasoline waiting at the corner service station. So that is just it. What is the definition of a flange? By definition, a flange is a device that controls the flow of a fluid. Yes, it controls the flow of a fluid. Yeah, because what does these valves do? It controls, it regulates, it it regulates the flow of a fluid. It shut down the flow of a fluid also. So there are several valves that are used in the industry, but let me introduce you to the various valves that are used in the process industry. We have the ball valve, the gate valve, the glow valve, the pressure relief valve, the check valve, and the butterfly valves. These are the common valves that are used in the process industry. And the control valve, yeah. So these are the common valve, the gate valve. Gate valve is used for non-throttling application. Non-throttling what? Application. Why? It is either they are fully open or fully closed. There is no minimal of obstruction or less you are damaging the gate valve. So it is mostly used in water line. Yes. And it has a stem. It has a stem, and there is a gate here that closes when the stem is open, and it has a stem and handle. When you rotate this handle, the stem tends to pull up and then the gate here opens. But when you rotate it the other way around, the the stem lower down and the gate also goes down. So that's how it's been what operated. But the operation and how it's been operated doesn't really concern us. I know that many of you will be asking, or we want to ask, how do we know the kind of valve to actually place on the piping on the system? There's what we call piping and instrumentation diagram, which the process engineer will develop and give to the piping engineer in order for him to develop his facility. So this piece of information called the P and ID will help you in a very good way to determine what to do, to determine the kind of valve that is supposed to be on that line, the kind of valve, the type of valve that is supposed to be on that line, and so on and so forth. That will tell us. That will tell us. So that is just the P and ID will tell us what valve to use and how to use it, and direction of the valve where it is opening to. So that's just now the glove valve. The glove valve is used to regulate a commodity. Now this one is used for throttling application. It's used to regulate the flow of fluid passing through a line. That's what the glove valve is used for. Similar application of that of the gate valve. No, similar way of operation as that of the gate valve. Sometimes actuators are being used in order to help us not to operate those valves manually. Angle valves are examples of angle valves are your pressure relief valve. They are used to for pressure safety and to relieve pressure of a pressurized vessel or a pressurized line. That's what it is being used for. So check valve is used to make sure that that fluid doesn't return back. It goes in one direction and just one direction. It helps to prevent fluid from backflow. So that's just what it does. So the ball valve is is an inexpensive alternative of the other valve. It has a ball in it that you close and you open. It is just like the gate valve, but more used in various ways, even in gas line, in water line, and so many other. You use the ball valve for such an operation. It is a multi-purpose valve. So why the butterfly valve? It's like the ball valve, but it is used in mostly water line, just like it has it looks like a butterfly, but more of of a circulatory plate inside of it that you can squint. It's either fully open or fully closed. So that's just it. So a control valve can be any kind of valve, maybe a diaphragm valve, a glove valve, a gate valve, but that has an automatic on auto emitted system of adjournment, maybe connected to a sensor in order to operate in a certain way. And anytime you have this control valve, always know that there is a bypass line in order to, in case of maintenance of that control valve, flow can still continue. Just that they just have to close the flow that is going to the gates, to the control valve, and then open the bypass. So that's just it. So that is that. Then valve operation. Valve operation can be done either manually or with the use of actuator. So once you use actuator to, it can be in form of hydraulic, pneumatic, or electrical control, air pressurized operation. So that's the use of actuators. It is used to control valves from the control room than using manual way to control the valve. So that's just it.